Hey learners, welcome to EdTube, your learning partner. So, this is a series on engineering thermodynamics and we are in the first chapter, Thermodynamics, Basic Concepts. In this video we will be learning about thermodynamic systems. A thermodynamic system is a region of space or a finite quantity of matter that occupies a volume and has a boundary. It can be separated from its surroundings by a boundary, which can be real or imaginary. Basically, it's the region or matter which is being studied or analyzed. It may allow the exchange of energy or matter or both. Understanding thermodynamic systems is crucial for analyzing and designing various energy-related systems. For example, the gas in a cylinder of a reciprocating engine is a finite portion of matter and, therefore, it can be considered a system. The water in a water bottle is another example. Now, let's see the characteristics of a thermodynamic system. We'll use a simple example of a water bottle to illustrate these concepts. System. The system is the region of space or quantity of matter that we're interested in studying. In this case, let's consider the water inside the bottle as our system. Surroundings. The surroundings are everything outside the system that interacts with it. For our water bottle, the surroundings include the bottle itself, the air around it, and the table it's sitting on. Boundary. The boundary is the interface between the system and the surroundings. In this case, the boundary is the inner surface of the water bottle that separates the water from the bottle material and the air outside. Universe. The universe includes both the system and the surroundings. It's the entire region that encompasses everything that interacts with our system. In this case, the universe would include the water, the bottle, the air and everything else that might interact with our system. Understanding these concepts is crucial for analyzing and designing various thermodynamic systems. By defining the system, surroundings, boundary, and universe, we can better understand how energy is transferred and transformed within a system and between the system and its surroundings. Now, let's see the different types of thermodynamic systems. We'll be discussing all the types of thermodynamic systems with some real-life examples to help you understand each type. Firstly, a closed system. A closed system is also called as a non-flow system. In this system, the mass or gas within the boundary remains constant. A closed system can permit exchange of heat and work, that is energy, with the surroundings, but does not permit any mass transfer across the boundary. A great example of a closed system is a tea kettle. The tea inside the kettle is our system, and the kettle itself is the boundary. Energy can be transferred through the boundary in the form of heat, but no mass is transferred. The cylinder and the piston of a reciprocating engine containing gas in the cylinder is an example of a closed system. Open system. An open system is also known as a flow system. In this system, both mass and energy, that is heat and work, cross the boundary. The mass within the system may not be constant. An open system is also called as a control volume. A particular example of an open system is that of a reciprocating compressor. Boiler in a power plant. Water is pumped into the boiler, heated to produce steam, and then the steam is used to drive a turbine. In this system, mass, that is water and steam, is transferred in and out of the system, and energy is transferred in the form of heat and work. Other examples include turbines and heat exchangers in which the fluid flows through them and heat or work is taken out or supplied to them. Isolated system. In an isolated system, there is no interaction between the system and the surroundings. It is a fixed mass and energy, and there is no mass or energy transfer across the system boundary. The universe, which constitute a system and its surrounding taken together, is an example of isolated system. Another example of isolated system is a thermos flask containing a liquid. Now, it's worth noting that perfect isolated systems don't really exist in real life, but we can consider a well-insulated thermos flask as a close approximation. If the thermos flask is perfectly insulated, meaning no heat transfer occurs, and it's been sealed so tightly that no mass transfer occurs either, then it would be an isolated system. Here is a visualization of the three types of systems. In an open system, both energy and matter are exchanged. In a closed system, only energy is exchanged. In an isolated system, There's no exchange of energy and matter. Now there's another type of system to know about.
The adiabatic system.
It is a system which is thermally insulated from its surroundings. It means that no heat transfer occurs between the system and its surroundings. While perfect adiabatic systems don't exist in reality, many systems can be approximated as adiabatic. For example, insulated pipes and tanks, thermos flasks and vacuum-insulated containers, certain industrial processes, such as adiabatic expansion or compression. Now we will look into another set of classification of thermodynamic systems that is, based on the phase of the system. So before that, we should know what a phase is. A quantity of matter which is uniform throughout in physical structure and chemical composition is called a phase. Every substance can exist in any one of the three phases, that is, solids, liquids and gas. Types of systems based on phase. Firstly, homogeneous system. A system which consists of a single phase is known as a homogeneous system. The examples of this system are water, ice, mixture of air and vapor, mixture of ammonia in water, water plus nitric acid, etc. Secondly, heterogeneous systems. A system which consists of more than one phase is called a heterogeneous system. The examples of this system include water plus steam, ice plus water, mixture of water and oil, mixture of water and sand, etc. In conclusion, homogeneous and heterogeneous systems are two fundamental types of systems based on phase. Understanding the differences between these systems is vital for analyzing and designing various systems in various fields. Thank you for your attention. This is all for this video. Stay tuned for the next part. If you found this video useful, make sure to like and subscribe for more content. Don't forget to hit the notification bell for more updates. See you in the next